Okay, so for percent yield, which is the last part of our notes, we're going to be using this equation. Actual over theoretical times 100 gives you percent yield. So everything that we've been doing so far when we do a stoichiometry problem, we're actually calculating the theoretical yield, which is what we could get if the world was perfect, smelled like roses, and we could all eat chocolate and it wouldn't give us acne or make us gain weight. But the world is not perfect, so because it's theoretical, you have to know how much you could get in theory to know what your percent yield is. And this is something that manufacturers use quite often, because if you're in the business of manufacturing goods, you want to get the most product that you can make, because if you make more product, you make more money, okay? And so whether you're at a refinery and making jet fuel where you have your feedstock, you want to know what's your percent yield. How am I making as much as possible out of my feedstock? Or you're at the Oreo factory and you put all your ingredients in there and you want to make Oreos, okay? The more you can make for the reaction, the better and more money you make. So that's where percent yield comes in. So what we've been calculating so far is theoretical, okay? Here are several reasons why you don't get 100% yield, okay? Many different reasons. If I give you the example of making cookies, okay, if I put, let's say, 150 grams of ingredients in there, am I going to get 150 grams of cookies? No, I'm not. Why? And we're not counting eating the batter, because that's the best part. What are some of the reasons you would not get 100% yield on a cookies? Water evaporating, although if we had a closed system, we could still maintain that mass. We could get that mass if we were in a closed system. What are some other reasons that you wouldn't possibly get the same amount?
Chemical reactions would make it.
But that's conservation of mass. Yeah. Why do I not get it when I bring it out of the oven? Even more simple, before you ever put it in the oven. It sticks to the bowl, right? You can't get all those ingredients in there, so you lose some that way. So there's an example. Sometimes some reactions have side reactions going on. The reaction doesn't go to completion. Because when we look at these and we're calculating, we're assuming that reaction goes to 100% completion. You'll find out later that actually most reactions don't go 100%. They reach an equilibrium point and then they stop. Okay. So some definitions. Theoretical yield, what we've been doing, is the expected amount. It's what you should get. Okay? It's the answer to our stoichiometry problem. Okay? The best case scenario, assuming that nothing goes wrong in the world. Okay? The actual yield, are you ready for it, is the actual amount. I know. Okay? This can only be determined in the lab. You have to go into the lab and do it. Okay? And so you can calculate what you should get, but you'll actually probably get something different. And that's what our lab is going to be on Thursday. We're going to do a stoichiometry lab. We're going to form a precipitant. We're going to filter it. We're going to let it dry over the weekend, and then come back and get a mass of that. And we're going to have an actual yield. But then we'll need to calculate our theoretical yield based on the amounts of reactants we put in there. And then you'll calculate your percent yield. Now, if you get more than 100%, you did something wrong. Okay. Because you should never get more than 100%. That's why when someone tells you to give them 110%, you should look at them and say, that is not possible. Okay? And you can tell them stoichiometrically so they think you sound really smart. Stoichiometrically, what do they mean? It's not possible. Okay, so here's the formula we're going to use. It's just going to be a little extra step at the end of the problem. You'll be given the actual yield. Sometimes we might give you the percent yield and actually ask you to solve for actual, which is algebra, just basic algebra, okay? But you want to look for these words like produced, formed, isolated, collected, to know that that's talking about an actual yield, okay? Don't start the problem with the actual yield. You will not get the right answer. All right, so here is our example. We have zinc citrate, which is an ingredient in toothpaste, and we have this reaction. It's already balanced for us. By the way, on your worksheet today, I believe they're already all balanced. And I think they're already all there. You don't even have to come up with the equations or the formulas. You're welcome. Okay. So here we have 6 moles of zinc oxide and 10 moles of C6 and that the rest of that stuff in there. It says calculate the percent yield if 990 grams is actually collected from the reaction. So when you're reading through these problems, it's a good idea to go ahead and circle it and then write actual so that you don't, on accident, start with it. You don't want to start with that. We're not going to use that till the end. Okay? So we have 6 moles and 10 moles of the reactant. So what kind of problem is this first and foremost? Limiting.
Yeah.
It is moles to grams as well, but it's going to be limiting because we have 2 reactants. Okay? So it doesn't matter which one we start with. I always start with what they gave me first because it's just habit. So I have 6 moles of zinc oxide. And when I start with moles, I can do a little bit of a happy dance because where can I go straight to now?
Grams.
No.
Mole ratio.
Mole ratio. Okay? So we look at my balanced equation, and for every 3 moles of zinc oxide, I make 1 mole, and I'm going to abbreviate zinc citrate because I don't want to write all that out. Okay? I cancel. I have now gotten myself into moles of zinc citrate, but it wants mass. So, I need the molar mass. I will not make you calculate that. I will give it to you. It's rather large. It is 574.39. Okay? So, when I do my handy-dandy calculator, I get 1150 grams of zinc citrate, but I do not know if that's my answer yet, do I? Because now I got to go do this 10 moles of the C6H8O7, which is the citrate of zinc citrate. My mole ratio is 2 to 1. Oops, sorry. Erase that. Got ahead of myself. And then same molar mass. It didn't change in the last 2 minutes. Maybe it will tomorrow. And when I do my handy-dandy calculator there, I get 2,870 grams, which is not my answer. Mark it out. Why is it not my answer? It's too big. We run out of the zinc oxide first. So this is my theoretical yield right here. Theoretical. Because once I run out of the zinc oxide, which is my limiting, right? Whoops. That's very messy. It says limiting. Sorry, it's really messy. Okay? So now I know how much that I theoretically should make is 1150. So now I can do a percent yield. Actual over theoretical. Here's a hint. Your theoretical, your bigger number should always be on the bottom, unless you messed up and you got too much stuff. Which in the lab on Thursday, every year there's people who get a little too much stuff. So if you get more than 100% on your lab, you're going to need to explain why. What was your error? So 990, they gave me in the problem as my actual yield. It said I collected it. And then we're going to divide by the theoretical.
We need significant figures for this.
Well, you know what my answer is going to be. Yes. How many significant figures do I need? Who said 2? Pat yourself on the back. There's only 2 in this number right here. So it's 86%. Yeah, because they gave us 990, which was 2 sig figs. Now up here we needed 3. Up here and here because we started with 3. Okay? Any questions on this? Okay, on your worksheet today, okay, it's kind of thrown a couple of people for a loop today when it says, like number 1 says, you have some copper reacting with excess chlorine, okay? When you see the words excess, that means you get to ignore that in the problem because you're not going to do anything with it. If it says it reacted with excess, whatever the other reactant is, that means it's not a limiting reactant, okay? So, and then because it's not a limiting reactant, it doesn't care for you to calculate how much excess is left over. It doesn't give you any information. So the first couple of problems are just going to be a theoretical yield and then a percent yield, okay?